the last section of the descriptive statistical analysis. So we use the data explorer package to explore the data. You can do that before you start operating your data to look if there is any missing value, and it shows you the relative importance variable and which columns are useful for even machine learning and sample classification. So you load the data explorer package. Then you just you call the function which is create report from my data. So by calling the create report, create the HTML file, and it will be open automatically in the web browser. So you can see here basic statistical count, percentage, data structure, missing value, univariate distribution, histogram, bar chart with the frequency, QQ plot, correlation analysis, and the principal component. So this is the shape of the data. Total observation 750, which is 5 times 150, because we have 5 columns and 150 rows. So this is the total observation by each cell. So that split column, which is the species column, and the continuous column, the other 3 species, spectrum and spectrum. All the numerical column, which is these 4. This is the continuous column. So missing column or missing observation is 0, and missing column is 0 and missing observation 0. Complete row is 100% is completed. So this is the data structure, shows you the data structure as well. So here it's only shown two species, not the third one. This is the header name, all these header name. So missing data is all 0, so that means all the data is completed. So it comes to the distribution. So we have the distribution is accounted for only 4 columns, which is the petal length, petal width, and sepal length and sepal width. So the frequency is almost like 50, which is equal. Frequency bar chart for the frequency for only the species column, which is all 50. So if the data is different, or balanced data, for example, you will find it's 10 samples from only this species. Or you can decide if the data is comparable or not if you're running any machine learning models. So this QQ plot, which determines how the observation is far from the mean line. And this is the correlation analysis. So if you see all the one it's telling us that it's 100% is correlated. The negatively correlated, which is the blue, dark blue, and the negatively correlated, correlation. And the red one is positive correlation. principal component analysis for classification, which is the variance between the three groups is 62%. The variance between if you're using the PCA, or you create the PCA, which will show you three different groups based on the four values, which is the sepal length and sepal width and petal length, petal width.
Let's go back to the correlation.
Yes.
I didn't get to what you were comparing. I see the species. Maybe it's this one.
So if you look at this one, it's 100% correlated.
Okay.
But if you look at the spittle width and
The second
length are negatively correlated. You see, when it comes here, it's negatively correlated for this species. For this species,
that species compared to the second length,
It's comparing all the factors to each other.
all the factors. Okay.
The list on the x-axis and the y-axis are the same. Because it's the same. It's the same.
so here you see relative importance of the relative importance for each species. So for this species, you will find its negative values. So the most important values for classification is these are with the positive value for the BCA. This is for the BCA. And also you can, if you open the link for the original package, so this is the installation command, and this is if you install the dev tool. So this is what we have used now, and also you can use, you extract only the report that you want. So if you use the function introduce only my data, you will see something different or less data. Short report. So now you see just introducing the data, which is you have 150 row, 5 columns, stated column, which is the species column, character, which is one column, continuous column now 4, all missing column 0. So when you set the y as simple length, it will provide the data to ranges. So this one is the same, but this one divided into different ranges. You can see the number of samples here. So also you can combine the GG box plot for each column in the data set by using the define the data per species. So now we finish with the descriptive analysis, but I have to take you back to the start, because I think we jump into the descriptive analysis before we give the nice introduction to the R in general. So now can everyone clean the history and the environment? Free and used memory. So now can everyone start R fresh? You close and you open it again. So, using the get WD, just gives you working directory where you have working for where you have R environment currently. So if you see, I'm in home Nasali. This is what the machine name was, the home directory for this machine. So if you want to set work directory, you can navigate file. For example, if you want to go navigate by this file and you go to desktop, you go to training, then you say, you click here, then you set as work directory. So you can see in the bottom here, in the console, the bottom, it has set the work directory to desktop training 2024 NASA. Otherwise, you can use set work directory. You give the directory that you want from here. as work directory. Set as work directory. You check the work directory, it's home. Then you set the work directory to the same file path there. So get so that means by setting work directory and you give the file path and you check get work directory, you will find it changed from home here to training 2024. We use hash here for comment. If you want to write any comment inside a script, or you want to when you come later you understand what you did before, you write your comment for a specific function or tool you are using. So by using the question mark, using the question mark before the function, let's say get wd. So it will open the help for you. So get or set work directory. So it will open it this side. It will open it on this side. So if you want to install package, which we already did, you can just use install package. Install package, then you write give it ggplot, then you start to install the package. If you want to call the library or make it active in your work environment, you just say library ggplot player tidyverse. So tidyverse it's not the package it hosts function itself, but it hosts other packages, collection of packages, tidyverse. So you can load by library individually, or you might need to do it once or together as library tidyverse ggplot. So if I run it now, it's load the So now if you want to use R as a calculator or basic operator of R or basic of R, so if you're adding 2 plus 3, so this is used to add number. If you 2 plus 3 it gives you 5. If you divide 5 by 2, for division use the slash. So for this one, there is a mathematical order, which is division before multiplying. Multiplication. So 20 divided by 2 before 2 times 2. And this sign is for exponential. 2 exponential 2 is 4. So now we're using variable to set to store the value, which is x equal 2 plus 3, which is 5. You can call x directly, or you can use print function. You can call x directly or use print function to get the value of x. So because R is because it's R mainly used for statistic analysis and graph visualization, so there is a mathematical order that should be considered in should be considered. So this one, who can give us the answer of this one? Who can guess the answer?
Four.
Moving this part, so everybody tracks calculated.
It's not easy to find. Tony, you don't have answer to this.
21 and 3 over 5.
Almost.
Almost.
So this is how. This is the mathematics problem.
Yeah. So it's 20 times 2. Then what's 10 and 2 is 20.
So 20 divided by 10 is 2 times 10 times 2, 20. Then you divide 2 divided by 5, it's equal 1.6. 0.4. 0.4 then minus 2. Then you add it to the 20. 21.6. So this is the exponential. Now, what's equal to z now? 84 or 64?
64.
So now this comparison operator. So if you say what we did with top quantile and lower quantile, we use lower than or more than. So there's other comparison operator we can use, which is less than, more than, double equal, which is equal. Yeah. And exclamation mark next to the equal, which is not equal. Let's say if you have a vector with 2, 3, 4, give me any number is not equal to 5. We'll return all the value 2, 3, 4. And this one less than or equal, more than or equal, and this one is n. We can use an example. This one is n. So now when you're setting vector, which is could be characteristic or character or numerical. So this one, if you say plus vector 1, vector 1, numerical. So this is vector 2 as well, which is same numerical, and now result equal vector 1 in vector 2, which is only two number, which is 3 and 4, 5. It gives you true in three numbers. 3, 4, 5. So now in this one you created character factor, which is character factor apple, banana, and orange. Print. So this is the factor. But if you want to check plus, okay. Shows you its character factor. So now it's a logical factor which is true and false. If you say 3 equal 3, it won't turn back to your result as a 3. It will give it to you as true. So if you say 3 equal to 3, it's true. It's logical fact. So now also you can add two factors together, numerical factors. So this is the factor 1 and factor 2. So you use plus to add two factors. So it will add 4 to 1, 5 to 2, 3, and 6. So it gives back 5, 7, 9. Same if you multiplication, factor 1 times factor 2. Which is 3 times 6, 2 times 5, 1 times 4, which is gives you 4, 10, 18. So now we come to the if statement or if else statement. So if statement, it's conditional. So if the condition is true, execute. Execute if the condition is true. So for example, x equal 10. So now, if x more than 5, print x greater than 5. So what's the condition here? X more than 5. So now, guess that x is greater than 5. 2. Nothing turn back. Because the x is less than 5. So this is for the numerical value. Then we come to the character value. Beta, n equal beta, y is equal John David beta. So if n inside the factor which is including 3 names, which is beta is there, is n equal. So if n inside y list. So you beta and the list because so just to show you with this one. It's inside the list or inside the column. Even you can search inside the column. So now using if else, x equal 3. So if x more than 5, print x is greater than 5. Else, x is less than or equal to 5. So now it gives me x is less than or equal to 5. What if the x is more than 5? Let's consider. X is greater because the first statement, which is print, first condition, it's applied. First condition is applied because x is a little more than 5. So then it will print the first condition. This one is the same. So because x here is less, nothing. This one is the same. So for equal, just to use double equal as example here, it's at 1, 5. So if x equal double you put double equal next to each other. Yeah, 2 equal, which is mean equal to r. So now x, y, and y is 10. If x not equal to y, so exclamation mark and equal, that means not equal. So x 5 and y is 10. So if x is not equal to y, print is not equal to y. X is not equal to y. There's nothing. There's no output from it because x and y they are equal, both of them is 5. So same, you will use if x less than or equal to y, you say and you print same statement or same output, which is x less than or equal to y. So because 5 is less than 10, yeah. So this one is the same. More than or equal, distant. Greater than or equal. So now there is another operator which is logical operator. So we use double AND, which is shift 7, which is gives you double AND, gives you returns true if both left and right front are true, and or, which is not high, please. Tab. Return true if it's either the left or the right is true. Exclamation are not like let's say what we see, not equal. Exclamation mark. It's true. So now x equal 5, y equal 10. So if x more than 1 and y is more than 1, both are positive. More than 0, y more than 0, both of them are positive. So because y is more less than 0, y is equal minus 10. The statement it won't come out because y is minus negative value. So it's the same here. Pipe, yeah. So if you use double pipe, means all. So x equal 5, y equal 10. If x more than 0 or y more than 0, or positive. Yes, all y positive. So in this if statement, we have one value which is negative and the other value is positive. So if you say x more than 0 or y more than 0, you print out either x or y is positive value. So if not, which is inside the bracket is x equal to 10, but if you put the exclamation mark before it, not true. Like I mean, x is not equal to 10. So when it comes inside the statement, x is not equal to 10, which is true because of this the exclamation mark before the bracket. X might. So now to create a function, I use the body mass index as example. So you type calculate body mass index, then you get the function, which is so the function is calculate body mass index. You write the function, then in the body of the function, which is the output of the function, weight per kg and height, which is meter. So body mass index equal weight per kg divided by square root of height. So now if I run this function, then I give the weight is 70. The weight is 70. The height is 1.6. Then the body mass index. So I use the function that you will use now. Calculate body mass index, which is equal. You have to text the weight per kg and the height per meter. So the body mass index 27. Yes. What's the optimal body mass index for this weight? This height and this weight.
In male or female?
Can you send me the script as well?
So now we want to create dummy data or example data using this function. Dummy data equal open the bracket. So the ID, which is the first column, from 1 to 300. So that means I have 300 rows. So then it comes to the gender here. You say gender equals sample. You open bracket. For C, you have male or female. Then you say 300 times. It's repeated 300 times. Then here, replaces true. That means it's not like, if you say male and female, it does not have to come like, first 150 is a male and second is female, opposite. So for the age, you use the same age equals 100. The range of the age from 18 to 80 years old. Then how many times repeated is 300 times repeated. So replace is true. So it does not goes in descending or ascending order. So then you create another column which is income equal normal distribution 300 times. The mean is 50,000 and standard deviation is 10,000. So if I run it here,
How did you come up with those values? The mean and the
No,
standard? You had already calculated?
no, you decide. You're creating dummy data or example data or from scratch. You're creating a new data set. You want to use it for teaching or for any purpose.
Another question. If you had missing values, what would you do? Like
That process of data cleaning, we'll do it later after we do the data cleaning. But this,
90% of our is data
Huh?
cleaning.
yeah. So this is the dummy data. So we know we have 4 columns: ID, gender, age, and income. Then you say class data should be, and you want to create it as a data frame. Save it as data frame. Then you say dummy data equal as data frame function. So it will remove the table DF or table L. So it becomes data frame. So if you write the class again here, So now it's the data frame. So if you say dummy data, so we have 4 columns. So now if you're working with existing data and you want to add more columns, so using by, this is comes from the player, comes from the player. So use the dummy data. Dummy data is the original file. Still being signed, saying go to the original file and mutate. Mutate, you want to add the region, education and region. So education is high school, bachelor's, master's, PhD, and how many time? Let's say if we write 200, let's say, then it's replaced. So some rows it will be empty, some cells it will be empty from the Excel sheet. Then the region, we have 4 regions: south, north, east, west. So we have in A data now. So let's see. You see, it gives you the So now we change it back to 300 and create the data set. Now before we move to the subsetting of the data, let's try to make a similar report as in. So this is the data. Okay. There's no missing value. This is the goal here. This is how the data comes out. So you see the age, it's different. It's ranging from 18 to 20, below 20, 18, 80 years. Because you specify the age here. You give the age range that you want to see. So this is the age range, ID, income, education level, region, and the gender. So you see more or less equally in the term of region, more or less equally. Just the north, it has more sample than the other regions. In terms of education, PhD is more than the other level. So when it comes to gender, it's more male, which is more than 150, more than the half of the samples of the data. It's male. So this is the data distribution from the mean. This is the correlation. the highest BCA is 16, the values of the BCA. BCA values highest is 16. So relative importance.
Is it possible for PC to show us this that plot where you have PC1 and
BC2,
yeah. Is there an option in this for it to do that plot?
No, not in this page. I didn't see in this page. But, so this is how you create, for example, data set from, let's say, scratch or from using the table function, table function. So now for the subsetting the data. So now we know the data is 300 samples. For example, if you want to select only the female data, so if you are conducting study only in the female, let's say income or any other variables, their age or something like that, the data set. So you use the subset function. So let's see where it comes from, this function, the subset function. Should be base and data table. It should come from tidyverse data table. It's one of the packages inside the tidyverse. So now, subset, dummy data, the original file. So dummy data $sign, go to the gender column, which is I think the second column, goes to the second column, gender, then it selects gender equal to female. Then, which is mean dimension, so it gives you the dimension of the data set. It gives you how many number of rows, how many number of columns. The first one is the number of rows, 140 row, which is must be here now. Here you can see here 150 sample. So this is more than 150. This one a little bit than 150. This might exactly 140. 140 sample with 6 columns. So now, if you want to use another function which is filter, where you can set multiple, you filter the data multiple column or different conditions. So you use, you want to only extract the samples with PhD level, which is use filter PhD. You set the variable name like that or the data set like that. Then you go to the original file. You don't use this one. Don't use this one. You use the original file. Then you use pipe. Then you pass in the function to filter. So you filter age of 30, income more than 60, education equal to PhD. So now we only have 11. So let's try to mention them. We only have 7 males below this condition: age more than 30, income more than 60,000, education PhD level, gender it's male. So this is only 7 out. Only 7 out of this data set are male, PhD level, and income more than 60,000, age more than 30 years old. So now you can use also subset with the two conditions. So you make subset female data. That's dummy data, the original file. You go to the gender equal to female. Then you select only the 2 columns. So in the first one, we saw when we run the dimension of subdummy female, which is 6 columns, gives you 6 columns here. But here, you only extracting 2 columns. You are not selecting the whole data set, all 6 columns from the whole data set. So it gives you 140, but only 2 columns, picks up 2 columns. It was, so remember that R is case sensitive, like a bash or shell script. It's case sensitive, so if it's capital letter or space, it's very sensitive, it won't pick it up. So now because the female here was written with capital F, so you see the dimension, there's now dimension is only picks up the two column, the ID and gender. But if you turn it back, same as it's written inside the data set. So it gives us 140 and only 2 columns. You can use also this one, you select the column directly. If you are interested only in the column, but you are not filtering, but you just want to extract important column from the data set. So it gives us all the 300 samples with the 2 columns that we specify age and gender. So also the arrange function. So if you see the, let's see here, dummy data. If you see the age here, it's mixed, yeah? 52, 87, 71, 45. But if you do the range function, it will be descending order. It will put it in descending order.
And you have to do it here on the range data instead of dummy data.
Oh, yeah. So descending start from how many samples? It's 4. We have age 80. Then come down. And also you can, if you don't specify the descending, nice. So if you then set it as descending, descending comes from highest to lowest, but if you leave it default without any parameter, it takes from smallest to highest. Smallest to highest. So now there's other function which is mutate. So mutated data equal dummy data. So we have 6 columns in the dummy data. So age group, we want to see the age group. We want to say that if it's younger than 30, it's young. Older, it's old group. So age group equal, if else, age less than 30 is young. So if it's more than 30, 30 will get old automatically.
What if you want to have like 3 age groups?
Sorry?
What if you want to have like 3 age groups?
See here it's group.
Let's say, for instance, yeah, your
I think you keep mutating the same data set. Like I mean run one by one. So we add the age group. We add the age group to the original data set, which is this is the age group, new column. You see old and young. So now, if you have 2 different files or from same analysis but different time, you want to join the data. So I create a small data set just for example. So diff one data frame, which is ID equal C123 value, that's fixed to the ID, which is ABC. And diff2 or data frame 2, it's the C234 and the value XYZ. So let's see how we can join these 2 small data sets. So they are almost the same, like 3 rows and 2 columns, which is ID and the value. So now we need to do a near join. There's a function in deep layer package which is called near join. Near join is like intersection, managing the data intersection values, which is if you can see the data set here, it's only what is common ID, 2 and 3. 2 and 3, it's only the common ID. So when you do a near join by the ID, because the ID here it will take 2 and 3 from both data set. So it comes out 2 and 3 only here down. Only 2 and 3. Then it takes B and C. Value 1 and value 2. Value 1 comes from the data, from the div 1, data frame 1. Div 2 it comes from the data frame 2. So you can use left join and use the right join also. Then full join, which takes all the columns. So now you want to write reading the CSV file. Let's say div 3. So if I go to training 2024, there's no file called metadata here. So the file is here. This is the file. So you specify the path to the file here. Read CSV. Then you specify the file path, which is go back one step to the data folder. Then you read metadata from that file. Metadata from the data folder. The other case, when you're reading Excel or XLSX file, so you cannot use the read CSV for the Excel files. So you use read XL. So this one by the tidy persons, read Excel. This function comes from the tidy persons. And also read Excel package. So if your file is in the same directory, if the file is in the same directory as the work directory, you just read the file. So I have 49 column and only 9 sample or 9 rows. Can we do practical in this one? Practical, practice. Yeah, you run the script by yourself, all the script.
I'm not sure what you're asking.
No, we do practical on this script. Yeah, let them practice the.
Does everybody have access to this?
Yeah. So did you send it?
If you have an Excel file on your PC that you want to test this command on, that might be quite interesting. If you have a CSV file on your PC that you want to test,
No,
that might also be interesting.
field service needs to be followed.
The residence is connected to the system. It's a field.